All right, algebra students, we are on our last lesson here for chapter 7, 2.7. And this is what we're going to be doing. We're going to be solving absolute value inequalities. Okay, so the first one we're going to look at is this type right here. We're going to look at when the absolute value is going to be less than, okay, either less than or equal to or less than. Okay, so when x is over here on the less than side. So here's what it would look like. The absolute value of x, for example, would be less than 5. Okay, so what that means is we're going to jump down here. The solutions are all numbers between -5 and 5. Okay, so let me show you kind of what that looks like if we're using a number line. Okay, so here's our number line. We'll put down 0. We'll put down 5. And then -5. Okay, now remember, absolute value is the distance a number is away from 0. Okay, so at 5, we would have an absolute value of 5, and at -5, we would have an absolute value of 5. Okay, so but what we're looking for is an absolute value of less than 5. So we would want all of these numbers here in between 5 and -5, because these would all have a absolute value of less than 5. Anything up here is going to be greater than an absolute value of 5, and anything down here is going to be also greater than an absolute value of 5. Okay, so we want to stick right in this range. Okay, and we write it using an AND statement. Okay, so over here we could write our AND statement, or we got it written right here where we have -5. So x is going to be greater than -5. Okay, so we're going to be going this way from -5. Okay, and at the same time, x is going to be less than +5. So we're going to be going this way from +5 to show everything in the middle would all have an absolute value of less than 5. Okay, that range right there. Okay, so that's what we're looking for when x is going to be less than for an absolute value. So let's take a look at solving some equations and what that is going to look like. Okay, so here's our first one. Now notice right away, x is over here on the less than side. Okay, and what we need to do is cancel out anything that is not part of the absolute value, just like we did in chapter 1. Okay, so we're going to go ahead and do that. We're going to, instead of -3, we're going to add 3, add 3. Okay, so that's what we have so far. And our 3's are going to cancel. So we are left with the absolute value of x, the same symbol, and 4. Okay, so that's what we have so far. Now, what it's saying is that the absolute value of x is less than 4. Okay, so I'm going to set up a number line. Okay, same thing like we did on the other side. The other slide we have 0. Okay, put yourself +4 and put yourself -4. Okay, because remember, this can also be absolute value has two answers, 4 and -4. So what we're looking for is x to be less than 4, have an absolute value of less than 4. So we're looking at everything in between here from 4 to -4. These would all have an absolute value of less than 4. Okay, and because it cannot equal 4, we would have an open circle on -4 and an open circle on +4. Okay, so that would be our answer for the first one. It shows the absolute value of x being less than 4. Okay, the distance away from 0 is less than 4. Okay, so there's our first one. Let's check out another one. Okay, this one's a little more complicated. We got some more stuff going on. No worries, we're going to work it out. We're working these out just like we did in chapter 1. So this is the absolute value part. So I want to get that alone. So I'm going to cancel off the 4.5. So I'm going to go plus 4.5 on this side plus 4.5 on the other side. Okay, same thing we did like in chapter 1. All right, so when I do that, my 4.5s are going to cancel. And I'm left with the absolute value of x plus 3 on one side. Keep the same symbol. And then on the other side, I get 12. Okay, so that's what I have so far. And just like what we did in chapter 1, we set up a case 1 and a case 2. Okay, so this is our case 1. We can label that C1 because that's our case 1 that we're going to solve. Okay, and then I'm going to set up my case 2 down here, and my case 2 is going to be the same exact thing almost. Okay, remember we set up almost the same exact thing. We have x plus 3. Okay, now this symbol is going to flip and go the other way, and then we're going to put negative 12 at the end. Okay, so our symbol flipped. And then we do the same thing we did in chapter 1. We have a negative 12. Okay, so why did the symbol flip around? Because this over here in the original equation needs to be, the absolute value needs to be less than 12. Okay, so we need to go less than 12. So that means when we have negative 12 on the number line, we're going to make this part go more than negative 12, so that way the absolute value stays less than or equal to 12. Okay, so we'll set this up on a number line when we solve it, and then you guys will see what's going on. Okay, so let's just solve it. We'll go through our steps. This is our C2. Okay, it's all going to come together here. So we'll solve this one just like we did in chapter 1. We'll do minus 3, minus 3. Okay, so on this side we have the absolute value of x less than equal to 9. Okay, so we solved case number 1. Now we're going to solve case number 2. Same thing, minus 3, minus 3. Okay, so then now we're left with the absolute value of x is greater than or equal to negative 15. Okay, there's our two answers. Now we'll graph it and you'll see why we had to change that around, why we had to flip that. Okay, so let's graph this. Let's put ourselves a 0. We're going to have 9 up here on this side, and we're going to have negative 15 down here on that side. Okay, so there's our number line. There's our graph. Okay, let's take a look here. This x can equal 9, so we could have a filled in circle on 9. X can also equal negative 15, filled in circle on negative 15. Okay, now what we want is x needs to be all of these numbers in here, okay, because all of these absolute values would be a possible solution. Okay, so from the 9, we need to be less than 9, so we're going to go that way. Okay, so that part checks out. Then over here, check this out. We're going to have x is greater than negative 15. So going greater than negative 15, that would go that way. All right, and that's why we had to turn this around so that we wouldn't be going the opposite direction. All right, because then that means all of these numbers in here would all have an absolute value of less than 9 and an absolute value of greater than negative 15. All right, so that would be all of our possible answers for that. Okay, and we can make that into a statement. We can say, make it into an and statement, negative 15. Okay, x is going to be greater than or equal to negative 15. And also, x is going to be less than or equal to 9. All right, so that made our nice and statement there for that one. Okay. Try one out on your own, see how you guys do, and then in a couple minutes, we'll take a look at your guys' answer. Okay, so let's check this out, see what you guys came up with here. So what you had to do, this one was a little simpler. We divide by 2, divide by 2. All right, so then we get the absolute value of x needs to be less than or equal to 3. Okay, so when we set up our number line, here we have positive 3 and negative 3. They're filled in because they can equal 3 and negative 3. And then we're showing all the values in between negative 3 and 3 so that the absolute value is going to be less than or equal to 3. All right, all of this middle part is highlighted and filled in. Okay, so there's your answer to the try this. Let's take a look at what will happen when the symbol goes the other way, when the inequality goes the other way and x is greater than. Okay, so here we have x can be greater than, or x can be greater than or equal to. Okay, so what we want is all of the numbers. Okay, so here's our example. The absolute value of x is greater than 5. Okay, so we want all numbers that have a greater absolute value than negative 5 and 5. So if we put that on a number line, all right, here we have 0. Here's 5. There's negative 5. Okay, so there's our number line. And we'll get a visual of what this looks like. We want all the numbers that have a greater absolute value than negative 5 and 5. Okay, so 5 has an absolute value of 5. And negative 5 has an absolute value of 5. So that means we want everything on this side or that side, because going this way would have a greater absolute value and going that way would have a greater absolute value. Okay, so it turns into an or statement where this part in the middle is all less than 5 for an absolute value, and we want everything bigger. So it's going to go one side or the other, and the middle part is not going to work. All right, so let's take a look at solving some of these equations when x is going to be on the greater side. Okay, so here's our first one. We have x plus 2. The absolute value of x plus 2 plus 5 is greater than or equal to 18. So x is over here on the greater side. We need to get this part, the absolute value part, by itself. Okay, so we're going to cancel out the 5. So we're going to go minus 5, minus 5. All right, so then that's going to give me x plus 2 on this side. All right, keep the symbol the exact same. And then we're going to have 13 over here on the other side for this answer. All right, so that would come out to 13 on that side. Okay, so now we're down to just this part, the absolute value part. Okay, so we're going to set up our case 1 and our case 2. Here we already got our case 1 going on. Okay, now our case 2, we're going to do the same thing like we did in the previous problem. Okay, case number 2 is going to be written almost exactly the same. We're still going to have x plus 2 with the absolute value, but we're going to turn the symbol, the inequality sign, the other way, and we're going to make that a negative 13. Okay, just like we did in the other ones, we turn the symbol, make that negative. Okay, it's almost just like chapter 1. Okay, so now we're going to solve this. So we would solve case 1 by going minus 2, minus 2. We are left with absolute value of x greater than or equal to 11. All right, so there's the first one. Then we'll solve case 2, same thing, minus 2, minus 2. All right, so we get absolute value of x is greater than or equal to negative 15. Or less than equal to negative 15, excuse me. Okay, so now we got our two solutions. Okay, now we will graph this and you'll see why we had to flip that symbol the other way. Okay, so we'll put this on a graph. Here we have 0, we have 11, and we have negative 15. Okay, now looking at what we got here, we have the absolute value of x is greater than or equal to 11. So it can equal 11. So it's going to go be filled in circle on 11. X can also equal negative 15. Filled in circle on negative 15. Now x is going to be greater than 11. So we're going to be going that way to show all absolute values bigger than 11. Okay, and then the absolute value of x is going to be less than 15. So then we're going to go this way, okay, to keep going smaller, because it's going to go less than. Let's keep going smaller. Then that will give me all absolute values that are bigger than 15. Okay, so like going this way gives me bigger absolute values. Going that way gives me bigger absolute values. In this, in the middle, we don't have any of those numbers. Okay, so that's why we flipped it around, so that we can get our OR statement like this, where it can be bigger than negative 15 or bigger than 11. All right, check one out on your guys' own. Pause the video. Then in a few minutes, hit play and see what you guys come up with for this one. Okay, we'll take a look at what you guys got for this. All right, so to solve this one, leave the x plus 2, the absolute value part, like by itself and cancel off the 3. So we had to go minus 3, minus 3. So we're down to x plus 2 is greater than 2. Okay, so the x is on the greater than side. All right, so then we set up our two equations here. Here we have x plus 2 and the sign flipped with the negative 2. And then here was the original x plus 2 is greater than 2. Okay, so we got our case 1 and our case 2. So we come out to x is less than negative 4 or x is greater than 0. Okay, so this is what it looked like if it would graph. It can't equal 0, can't equal negative 4, but it goes greater than 0, less than negative 4. So that gives me all the absolute values from going that way and going that way, which is exactly what we want. Okay, if you are in my period 1 and 7, we're going to continue on with some word problems and take a look at another example. If you're in my period 4, you're going to stop right there because you guys have an assignment which is up on the board, and you guys can work on that. Period 1 and 7 will continue on. Okay, so the next part, we have word problems. Okay, so here we got a pediatrician recommends that a baby's bathwater be 95 degrees. Okay, but it is acceptable, put some brackets on there, it is acceptable for the temperature to vary from this amount by as much as 3 degrees. Okay, so the temperature could be 3 degrees lower or 3 degrees higher. Write and solve an absolute value inequality. We're not going to do that. Okay, we're not going to write and solve an absolute value inequality. But what we are going to do is find the range of acceptable temperatures, and we're going to graph the solutions. Okay, so we're going to find the range of temperatures and graph the solutions. Okay, fairly simple. Here's the ideal temperature. It can either go down by 3 degrees or go higher than 3 degrees. So really, you can go anywhere from 92 degrees to 98 degrees. Okay, 3 less than 95, 3 more than 95. All right, so to show that using a graph and an inequality, we can graph this. We're going to go 92, all right, and then 98, okay, and then to show everything in between that, it can equal 92, it can equal 98, and then we'd have everything in the middle. All right, so all those are acceptable. And then we can set up our AND statement with x, because this is an AND solution. So we can say 92 down here on this end, and then x is going to be on the greater than side of 92. And at the same time, greater than or equal to. At the same time, x is also going to be less than or equal to 98 degrees. Okay, so there would be our solution to that. That's all you got to do for these word problems. Don't worry about setting up the inequality. All right, try one on your own, see how you guys do. Pause the video, hit play in a couple minutes, and see what you come up with. Okay, so on this one, here is our acceptable range. 75 less than this and 75 more than this. So we're going to have, here's our 50 and 200. It can equal 50 or 200. We got all the numbers in the middle. And here is our AND statement. X is going to be greater than or equal to 50. And X is also going to be less than equal to 200. All right. Last ones we're going to talk about is like the weird ones, okay, the strange ones that we're going to run into. Okay, so the strange ones. So this is already solved for you. All right, so remember in like chapter 1, we didn't solve them if it was a negative, but because we got inequalities, sure, why not? We can solve them. All right, so look what goes on with this one. We're starting to solve it. We cancel out the minus 5, so we go plus 5, and we're left with x plus 4. The absolute value of x plus 4 is greater than negative 3. Okay, so in this situation, because this side is always going to be a positive number because of the absolute value, this is always going to be greater than negative 3. This answer over here will always be greater than negative 3 no matter what number you put in for x. Okay, so let's say you just try a random number. Let's say you want to say, I want x to be negative 50. Okay, so if you did negative 50 plus 4 in absolute value, that would come out to the absolute value of negative 46. And the absolute value of negative 46 is positive 46. And positive 46 is greater than 3, okay? So in this situation, if you run into something like that, basically, it doesn't matter. All real numbers are solutions, okay? Does not matter what number you put in for x, all of them are going to be a solution, okay? Everything will work. Does not matter. All right, so that's your first strange one. Okay, let's take a look at this one. Here we have the absolute value of x minus 2 plus 9 is less than 7. Okay, so we start solving this. We're going to cancel out the 9, leave this by itself, minus 9, and you have the absolute value of x minus 2 is going to be less than negative 2. Okay, this cannot happen because this side over here can never be negative. Okay, you can never have a negative absolute value. Okay, it doesn't work. This is always going to be positive, so this inequality has no solutions. There is no answers for this because we are never going to be less than negative 2. All right, no answers for this one. All right. Okay, we'll take a look at this one here because this one has like the greater than symbol. Okay, so if we go through and solve it, we would do plus 9, so we're left with the absolute value of x is greater than or equal to negative 2. Okay, the absolute value of x is always going to be greater than negative 2 because this is always going to be a positive value. All right, and you may be thinking like, well, Mr. Peterson, there's also the equal to part. The absolute value of x can never equal negative 2, so this equation can't be true. Well, it can be because of this. All right, that symbol here means this, greater than or equal to. Okay, it has to be one or the other. All right, so it does not have to equal negative 2. It just has to be greater than negative 2, which any number you put in here for x is always going to be greater than negative 2. So all numbers are going to work for this. All right, it doesn't have to just equal it. It is or, greater than or equal to. Okay, as long as it's one or the other, it works, and it will always be greater, so it works. Okay, the other one is if we're pointing back the other way, and we're at the less than with the x, and we have the greater than symbol. Okay, we go through and solve it. We would cancel out the 4, divide by 4, divide by 4. So you're left with x minus 3.5 is less than or equal to negative 2. Okay, that is not going to work. Okay, remember, this can never be negative, so it's never going to equal negative 2, and it's never going to be less than negative 2. Okay, never, never. So this inequality has no solutions. Unsolvable. You can't answer it. Okay, those are some of the weird ones. That's it for you guys for 2-7, and that is the end of Chapter 2. We'll be doing a review when I get back and then taking the test on Chapter 2. Go ahead and work on today's assignment, and I'll see you guys when I get back in class.